thank you everyone for coming back. We're going to do just a real quick recap of what we covered last week. If while I'm going over this or right now you already have some questions about what we covered last week, go ahead and throw them in the chat and I'll come back to those before we move into any new stuff. Additionally, if you need to re-download the materials, I think that the link to the Google Drive is pinned in the chat. I did include 2 new things in there. You don't have to have them to follow along today, but I thought I might include them just for demonstration. Because the point of learning SQL isn't necessarily just for the purposes of writing SQL, it's for working more efficiently. And it's to create visualizations that are really insightful and automated so that you can work really quickly. So I included 2 examples of products like that. One of them is an Excel file. And so I know that, if you are a data analyst, you might not have any other tool in the world, but you probably do have access to Excel. And so that Excel file is an example comp stat report, and it's like a data-driven policing meeting thing where we look at patterns and trends every week. And that's actually fully automated using SQL. So every week, whenever I would come into the police department, I would have a whole bunch of SQL queries made up in Microsoft Access. They would run, they'd pull data out of the RMS, they'd dump it into Excel, and then a whole bunch of formulas in Excel would do all our calculations for us, and then visuals would be built off of those automated calculations, and then the Excel would update itself. And so every week, whenever we had to do data-driven policing stuff, that didn't actually take me any time. I just came in, clicked the button, and we were good to go. Another example is Power BI. If you don't have Power BI on your machine, you're not going to be able to open that file. But I did want to just throw it out there as, these are all workflows that are automated because we're working with SQL. And if you don't know SQL, typically analysts have to rely on really manual processes. In fact, I'm working with a grant program right now, and we're working with a really major southeastern city to evaluate this crime reduction program that they started. And so, of course, in order to evaluate that, we have to get some crime data. And so we submitted a request last November for like 3 years worth of offense data, and we just got those returns back last week. And whenever we looked at the data, it was not structured data like an Excel or an XLS or a CSV format. It was just screenshots of the front end of an RMS because they don't have any SQL capability in that unit. So they have to, whenever they want to look at 3 years worth of offense data, they have to type in a date range into the front end of an RMS. They have to wait for something to pop up, and then they have to take a screenshot of it, and then they have to type in another date range, and they have to take another screenshot. So all of this is pointing us towards working faster and working more efficiently. And we can integrate what we're learning today with SQL and Microsoft Access with ARC Pro, with Microsoft Excel, with Power BI, or with any other analytic tool. And I'm going to end today by kind of showing you how you can do that. These are some example products that we made in Excel. Again, I'll come back to this. We talked about some terminology, about how a database is a collection of tables that all relate to each other. We talked about why you can't just have one giant spreadsheet, that you have to have relational data and tables that connect to each other in order to keep data clean and in order to keep it queryable. And we talked specifically about a table of incidents and a table of offenses and how they connect via these report number fields. And then later today, we're also going to get into querying individual data, so the people connected to offenses or the people connected to incidents. We talked about how relationships between tables can be one-to-one, like a table of people and social security numbers. Every person should only have one social security number, or they might be one-to-many. And that's the case whenever you have a table of reports and offenses. Every report can have multiple offenses connected to it, so that's a one-to-many relationship. And we're going to dive a little bit deeper into what that means when you're writing a SQL query on a table like that today, because as those relationships change, the results of your SQL query are also going to change. We talked about an example of a relational database where people are connected to vehicles. And this is an example of a one-to-many connection. So every vehicle can only have one person connected to it. And that works unless you have a situation where two people can be connected to the same vehicle or can be listed as owners in the same vehicle. And so in a case like that, our data structure changes from something like that to something like this, where people and vehicles are their own tables, and then there's another table in between them that shows connections of people to vehicles that you then have to perform a join to. And this is going to be particularly relevant when we start talking about pulling victim segments and offender segments, because we're no longer just looking at how many incidents are connected to how many offenses, but now we're looking at how many victims are connected to those offenses as well. And so we're going to run into a situation very much like this on the back end of a police RMS, where we've got people and we've got events, and then there's a table in between them that shows connections of people and events that we have to perform joins to before we can write a SQL query properly. Those are some examples of that structure. We talked about different types of joins, about how whenever we are writing a SQL query and we perform a join on two tables, what that's allowing us to do is create a new table that has columns from both tables. And so in the example that we're working through, we've got a table of reports, and that's represented by the table there on the left, and a table of offenses, and that's represented by the table on the right. We're going to join those two tables via report number so that we can create another table, and that's the one at the bottom, that has columns from both the report table, like date, time, location, and the offense table as well. And this is going to result in a form of duplication. So if you look at the table on the left, the report numbers can only occur one time because that's a table of unique reports. But when we join it to the table of offenses on the right, the resulting table, the report numbers can now occur multiple times. And that's because whenever you do a one-to-many join, we're now changing the unit of analysis from reports to offenses. So every report number is going to repeat for how many offenses there are in that report. We talked a little bit about SQL and the different things that you can use SQL for. You can limit data, you can transform data, and you can aggregate data. We talked a little bit about transforming data. I'm going to pick up there today and how you can aggregate data as well. So you can get counts of how many offenses occurred by code types and things like that. We also talked about different SQL writers. SQLite Studio is a favorite. Microsoft SQL Server is available. I tend, whenever I'm teaching SQL for the first time, to use Microsoft Access. We talked about it's super easily accessible. Chances are you already have it. You don't even have to ask IT for it. It integrates really well with everything. There's some really cool interface tools that are going to make automation a little bit easier, and we're going to talk a little bit more about those towards the end of our session today. Before you can really do anything with SQL, you have to have an ODBC connection. And ODBCs are just the connection between your computer and the back end of a relational database. It allows you to see all of those tables. It allows you to perform joins and write SQL and pull data out in a manner that is automated, as opposed to going to the front end of an RMS and, like the agency I'm working with, having to type stuff into a form and take screenshots and things like that. We can now pull structured data out. I did a real quick example of how to set up an ODBC connection. It takes 5 seconds. Oftentimes, the big hurdle, though, is you need certain information that typically either a database administrator or an IT department are the only ones that have. And sometimes getting them to give you that information can be a little bit of a political battle. But there really is no way to do automated analytics without this. So it is a really important step. We also talked about different types of query. For the purposes of our class today, we're really going to just be focusing on make table queries. And this just basically, like I was saying earlier, it allows you to view the backend tables, join them together, and create a whole new table of data inside your Microsoft Access database, which lives on your computer. That is the result of that query. And then this is kind of where we left off. We had done an example query. We had performed a join between an incident table and an offense table. We had selected columns from both tables, and we were making a brand new table from both of them. And then we were also talking about criteria where you can limit it down. So you can pull data that's only within a certain range, or offenses that are only a certain code, things of that nature. And so if you were following along last week, you probably have a query somewhere in your Access database that looks a little bit like this. We've got our incidents table and our offenses table. We got them joined by report number, and then we pulled some fields in here, and we were talking about different criteria that we can add to filter this data down even further. But if we were to run this query, this is a make table query. Well, I think when we left off, we were still running a select query, and if we run this, we can see the resulting data. And so that was just a real quick recap of everything that we talked about last week. I know it was a lot. Are there any questions before we move on? I'll just check the chat real quick. If any come up as we keep working, I'm going to end with a few minutes left at the top of the hour. And so I'll come back to the chat. And if there's anything that we want to talk about, I'm more than willing to go after 2 o'clock with anybody if anyone has any questions. Of course, you can also shoot me an email, and I'm more than happy to follow up with you after the class as well. So for those of you who might be a little far behind, just to real quick catch anybody up who may not be at this point yet, in order to create this query, we opened up a brand new instance of Microsoft Access, and you can do that just by clicking on your Microsoft Access icon and hitting blank database. We went to external data and we said, all right, we need to get a new data source from database, and we chose Microsoft Access. We're going to link to the data by creating a link table. And then we browse over to that journ database that is in that folder that you downloaded. And then you should see those four tables: incidents, offenses, person event, and person table. There they are. And then you can click on each one of those and click OK. Those tables then are going to show up as options here. If you double click on them, you can see the data underneath. And then we went to create and query design. We pulled our incidents table in and our offenses table just by clicking and dragging. We then connected these two. We performed an inner join by connecting report number. And then we just added fields by clicking on the different fields that we wanted from one table and the different fields that we wanted from the second table. And so we ended up in a place somewhat like this. Now, I began talking a little bit about ways that you can filter data down, and I kind of wanted to pick up there for just a minute. On dates, you can put in relative dates or exact dates. So for instance, if you wanted to see all of the offenses that occurred on September 1st of 2024, you would tell it that you want to look for a date by using a £sign and then typing that date in. So this particular query is only going to pull all offenses that are connected to a report number in the incident table, wherein the date occurred is 9/1 of 2024. And if we hit run, we can see that, well, there aren't any, so I picked a really bad date. But you can also, here, maybe if we put in 2023. Let's see what's going on there. These are date times. Date times are a little bit more difficult to work with, so I'm just going to skip that, but I am going to make the point that you can also put in relative dates here. So you can put in, you can use a between function here. So in our criteria, if we were to put in between 1/1 of 2024 and 10/1 of 2024, not a $, it's a £sign. There we go. Now we're seeing all of our offenses that occurred from the beginning of this year through the beginning of October. The reason one date in particular isn't coming back whenever I type in just one date is because those are date times. So there is no row with a date of just 1/1/2024. It all has 1/1/2024 and a time. You can also use functions, and typically I'll do something relative whenever I'm building something like this out, and I'll use greater than or equal to. But I won't type in an actual date. I'll use the function now with an open parentheses and a closed parentheses. And if I always want this query to run and pull in, let's just say 3 years worth of data. There's 365 days in a year. There's 1,095 days in 3 years. So you can say, all right, I only want to pull stuff that is greater than or equal to now minus 1,095 days. And now every time this query runs, it will always pull in 3 years worth of offense data. We talked a little bit about placeholder queries. Something that we didn't talk about much was calculated columns. And so I mentioned earlier that SQL is a way to limit data down to just data of interest, but you can also transform your data and even add new data to your query as you go along. And so one really critical way to do that is to create calculated columns. And calculated columns are formula-driven columns. They don't actually exist in the data. You create them via the query. And a really easy example of that is a calculated column that concatenates an address. And so I'm going to zoom in a little bit here, and I'm going to demonstrate how you can make a new column. So a lot of visualization tools, especially GIS tools, whenever you actually put data in and you want to point plots on a map, you have to have a complete address in one column. And so as you can see right now, we've got street number, street name, suffix, city, and state all parsed out into different columns. And so if we wanted to put this into like Power BI and get a map with all of these points on it, we would need to concatenate this at one point. And it's really important to do this with SQL, especially if you're working with big data. Whenever you pull data into Power BI, you can use Power Query to do this, or you can even write a DAX statement, but it's always computationally faster to do this type of work using SQL. So I'm going to create a new column, and to create a new column, I'm just going to come over here to this empty field space, and I'm going to type the name of the column in, and I'm just going to call this address 2, and then follow it up with a colon. And that tells Microsoft Access I'm creating a new column called address 2, and everything after the colon is going to be the formula that I put in to create this column. And so I can use a concat function here. If you're familiar with Excel functions, this is very similar. But I'm actually just going to use and signs here. And so I'm going to start off by referring to the street number field. And to do that, I'm going to open up a square bracket, and I'm going to type in street number. And you can see that there's a street number field over here. It comes from the incidence table. And so right now, all this formula is doing is saying, okay, we're going to create a new column called address 2, and it's going to start with whatever is in the street number field for this particular row. And then put an and there and a space. So I put an and sign, I open a double quotes, I put a space in, I put a second and sign in, and then I can put in the street name. Again, I'm just referring to this particular field. And then I might also put in an and sign and a space, and then put in the city. And then another and sign and a space, and put in the state. Now, whenever I run this query, I've got this whole new column over here that shows me the entire address, and I can use that for mapping purposes. There are also all sorts of useful functions that you can call while making calculated columns. And one of the most useful ones is trim. So I'm going to kind of skip around on our presentation here a little bit. Here we go. So there are a whole bunch of different really useful functions. There's something like 800 of them that you can call, and you can nest them inside each other. But some of the most useful ones that I use frequently, first is trim, left, right, change date, change to double, change to string, and then the date value field. I'm going to talk about 2 of those today. The first is trim. Now, trim is really important because police department data is notoriously horrible in terms of its cleanliness. So, for instance, this is actually, I was working with a police department and we were pulling some data. We set up some SQL queries. The SQL queries were feeding into Excel, and then we were creating some graphs in Excel based off of the SQL queries, and the graphs were coming up wrong. And we couldn't really figure out why these graphs were wrong. And the problem was that the data that we were pulling had leading and trailing spaces. And so when I would pull a table of data, it would look like this over on the left, and that looks like 313A. Those look like 3 aggravated assault offenses, right? But whenever we put these into a graph, it would just show 1. And I was getting really frustrated. I couldn't understand why. Well, you had to click on the actual cells to see that those actually weren't three 13As. One was a 13A, but then the second one was a 13A with a space on the front of it. And the other one was a 13A with a bunch of spaces on the front and the end. And I've run into this so many times, and my visualization tool wasn't counting all of these as 13As because technically speaking, they weren't. So in order to clean this up, I used a trim function. And the way trim works is you simply call the function trim, you put in the field that you want to trim inside it, and it takes out any leading or trailing zeros. In this case, I was trimming the address. So as you can see my syntax there, in my field, I typed in the name for the column, which is just trimmed underscore address with a colon. Then I called in the trim function, and I opened a parentheses, and then I put the address field inside. If we wanted to do that inside our query, so let's say that we wanted to trim the offense code or the offense type to make sure that any visualizations we were going to do later were going to be accurate and they weren't going to be inaccurate because of leading or trailing spaces. I can just come in here to my blank field. I'm going to give this field a name. We'll call it trimmed offense. So I'm going to type in trimmed offense, and I'm going to put a colon there just to indicate that I'm creating a new column called trimmed offense. And then I'm going to call in the trim function by just typing the word trim and opening a
Hey, Charlie, are you there? We can't hear you. Oops, hang on a minute, everyone. It looks like Charlie's having some difficulty and got bumped off. Let's see if he can get back in here quickly.
Hey, can everyone hear me okay?
Yep.
Yes, thank you, Charlie.
Sorry about that. My Wi-Fi in my apartment gave out, but fortunately I got a phone, so I just switched over. All right, so I'm going to pick up from where I think I was. We were talking about using different functions, trim in particular. So we talked about using the trim function to take out leading and trailing spaces. Does everyone see my screen okay? Yeah, all right. So to do that, I've got my query set up over here. I'm just going to click into a blank field, and I'm going to give this new column a name. So I'm going to call this trimmed offense, and then put a colon there. And again, all the colon does is tell Microsoft Access that everything before the colon is the name of the new column. Everything after the colon is going to be the formula that we're going to use to create this column. And then I'm going to call in the trim function. I'm just going to type the word trim in, and I'm going to open a parentheses. And then I have to tell it, what do I want it to trim? And I want it to trim the offense type column. So I'm going to open a square bracket and type in offense space type, close the square bracket, and close the parentheses. And when you click out of the box, if it doesn't give you any sort of error, you know that it's accepted your function as proper. And whenever I run this again, now I've got a new column called trimmed offense, and I've got the same data that is over here in offense type, but I've made sure that now this doesn't have any leading or trailing spaces. So in the future, when I dump this into a visualization tool, I want to make some sort of report, something like that, I'm going to analyze this column over here because I know that this column is accurate, whereas this column might throw me off. So I'm actually going to save this query, but before I do that, I want to change it to a make table. And so to do that, if you come over here back to your query view and you go to query design, you can go to this make table button. And when you do that, it's going to say, hey, when we run this, we're going to make a new table. What do you want to call it? And you can type whatever name you want in here. I'm going to call this one offenses NIBRS. I'm going to make sure it's saving to the current database, and I'm going to click OK. I'm going to right click on this tab up here that says query 1, and I'm going to hit save. And now you can see down here, there's this new query 1 button under query that has this little table with a little yellow starburst and an exclamation point. You can close this. And whenever you double click on this, it's going to say, hey, you're making a new make table query. Do you want to delete the existing table? I'm going to say yes. It's saying, hey, you're going to put 28,000 new rows into a new table. And my offenses NIBRS table is created just up here. And we can see the result of that query. Now, tomorrow, whenever I come into the office and I want to update this, remember that when I designed this, I said, hey, I want you to pull everything that was 3 years old or more recent than that. So everything in the past 3 years. So today, this is going to pull everything between October 4th, 2023 and today. Tomorrow, when I want up-to-date data, all I have to do is come in here and double-click on this and hit yes to all of these warnings. And now this offenses NIBRS table is going to contain up-to-date data for the past 3 years. So having a table of offenses is great. However, NIBRS reporting often has you count offenses a little bit differently. So to this point, our query has looked kind of like this. We joined a table of reports to a table of offenses, and you can see every report in the report table. The report number field is what we join on. Those report numbers can duplicate in the offenses table, but not in the reports table. And so the resulting query is going to produce a table where every row will represent a combination of reports and offenses. So one thing that trips a lot of new analysts up is the idea of duplication. The relationship between offenses and reports is one to many. One report can be connected to many offenses. So when you make that join and you query, the number of rows that you're going to have are going to be 1 times the number of offenses. So when we look at our resulting table, that report number, which is distinct in the reports table, can duplicate however many times there is an offense. When we start to look at people, this is going to change again, because in order to pull how many people were involved, how many victims there were, we then have to take our offense table and join it to a table of people roles. This is that table of combination of people and offenses together. This is now going to change how many times you can see the same report number duplicated in your result. It's now not going to be 1 times however many offenses there are. It's going to be 1 times however many people are involved. So if you have one report with 1 offense on it, but there are 5 victims to that 1 offense, in our resulting table, we're going to see rows with that report number 5 times on it, 1 for each victim of the report. This is important to point out and to train NIBRS analysts on, because when we do NIBRS reporting, there's kind of a question of, well, what exactly are we reporting? Are we reporting offense segments or victim segments? That's the terminology that comes from the NIBRS handbook. And basically what this is telling you is saying, okay, when you report to NIBRS, you're going to report offenses, but you have to report that separately from victims and offenders, because one report can have 1 offense and that 1 offense can have 1 victim. That would be 1 offense segment, or that 1 offense can have, let's just say, 10 victims. That's going to be 1 offense segment and 10 victim segments. This is the wording from the NIBRS handbook about victim segments, and every victim segment talks about information connected to each of the victims of every offense. So I know that a lot of you are taking this because ultimately we want to create statistical reports. And there's a real question here about when you create a statistical report for a particular audience. When you say there were 5 robberies, what does that mean? Does that mean that there were 5 robbery events, or does that mean that there were 5 robbery victims? And you have to have that in mind before you sit down and you write SQL, because what you're counting is obviously going to have a huge impact on the accuracy of your analysis. Whenever I work with individual police departments and they're setting up analytics and they're just looking within their city from year to year to see if offenses are going up or going down, I typically build all of those analytics off of offense segments. And the reason is because if last week we had, let's just say, 10 offenses, each one connected to 1 victim. And so we set up some sort of task force that was going to go out there and try to proactively prevent that type of offense. And then the next week we only had 1 offense, but that offense had 10 victims attached to it. Well, if we're counting victim segments, there were 10 victim segments each week. But if we were counting offense segments, there was 10 one week, and then we did this proactive thing, and then there was only 1 the next week. Is it accurate to say that crime went up or down, that we had any sort of impact? It really depends on whether or not you're counting offenses or counting victims. So whenever I work within a police department and we're only comparing that police department's numbers to previous numbers, I build those analytics off of offenses. In your role, you guys are very often looking at multiple departments across multiple cities. And when you compare cities to each other, you have to control for population. It's not fair to compare a count of the number of robberies that occurred in the city of Atlanta to the city of Decatur, because one is just massive. So when you're comparing across cities, you will often look at victims because we ultimately want to get that down to a victimization rate. We're going to look at the number of victims and we're going to divide by the population. So creating a query that allows us to to count victims is going to look a little bit different. Now remember, in our when we were talking about this, we talked about how there's often a table of people and a table of events or offenses, and then a table in between the 2 of them that connects people to events or offenses, sort of like the back end of Versaterm. Well, we have the same thing going on in our test data. If you go back to Microsoft Access, you've got this table of offenses. You've got this table called person table. And there's nothing inside person table that will connect to the offenses table. The offenses table has an offense number. The person table has a person ID, but there is no field that will join the 2 of them together. But if we look at this person event table, we have a person ID, and that will join to the person ID column in the person table. And we have this offense number column, and that will join to the offense number in the offense table. So we have to join people to offenses through this other table. And let me show you what that looks like. So I'm going to come up to create. I'm going to hit query design. I'm going to pull in my person table. And then I'm going to pull in my offenses table. And then I'm going to pull in my person event table. And now I've got this person ID column in the person table, and that will connect to the person ID column in person event. So I'm just going to go ahead and make a join there. And again, I'm going to do that by clicking and holding person ID and dragging it over to person ID in this person event table and letting go. And then I'm going to join offense number in this person event table to offenses via the offense number column in offenses. Now, we've already joined offenses to incidents in another query. If you want to go ahead and do that again, you can. And we join incidents to offenses by this report number column. So now we've got 4 different tables that we've joined together. And now we're going to create a query that's going to allow us to create a new table that has columns from all 4. And if we're kind of thinking of report number as like our main identifying ID, that is going to duplicate on every row for however many people were involved in that particular report. So let's see what we mean. I'm going to work from right to left. So I'm going to add report number from incidents in here and maybe the date. And that's probably all I need from there. And then I'm going to come over to offenses, and I'm going to put in the offense type. We definitely need that. That's our NIBRS code. And then I'm going to come over here to this person event table. And the only thing I really want from here is this role code. That's like witness, victim, offender, things like that. And then from the person table, I'm going to pull in a first name and a last name. And so what this query should produce now is a table of all people involved in all offenses connected to all incident reports inside this RMS. And so I've got this as a select query, so I'm just going to hit run. And this very first report number here that pops up for me is 13858. That is going to duplicate twice, not because there are two offenses connected to it, although there might be, but because there are two people. There's a suspect and a victim. I'm actually going to sort this. I'm going to sort largest to smallest. And we can see this, if you sort largest to smallest on report number, this one report, 19998, has a couple of different offenses. There's a 23D and a 9001. But each one of those offenses is connected to multiple people. So this 23D from 19998 has a witness, and it has an arrestee, and it has another. And this 991 connected to the same incident has a witness, and a couple of others, and a victim. So we're no longer pulling a table of offenses. We're now pulling a table of people involved in offenses because now we've performed multiple joins. And it's really important as you join tables together on the back end to keep track of what exactly it is that you're querying. If I was doing this in production and I was actually wanting to build out some sort of analytical product, the first thing I would do at this point is I would go look up report number 19998, and I would say, okay, based on this query that I've built, report number 19998 should have two offenses, a 9001 and a 23D, and it should have 1, 2, 3, 4, 5, 6, 7, 8 people in that report. 4 of whom should be others, 2 witnesses, 1 arrest, and 1 victim. And then I would go over the front end of the RMS, I'd type in that report number, and I would look at the offenses, and I'd look at the people involved, and I would confirm whether or not that was true. Then I would go down, and I'd pick another one. Look at 19990, and I'd say, all right, 19990 is 3 23Ds, and each one has a witness, an other, and an arrestee connected to it. Is that correct? Yes, no. So before I do anything else, I would confirm that I've pulled this correctly. Now, in NIBRS reporting, they talk very specifically and at length about victim segments and offender segments. But right now, we've got witnesses, we've got others, we've got all sorts of other things here. So if we wanted to ultimately use this data pool to create a crime rate, we would have to limit this down to just victims. And so to do that, we can go back to our query. I'm going to right-click on Query 2. I'm going to go to Design View. And then we can use this role code here to filter down. I'm going to tell it I only want to see rows wherein the role code equals victim. And whenever I run this again, now you can see this entire column, everybody's a victim. I'll right-click and go back to Design View. And maybe just like before on my date report, I want to set this up to run and pull me 3 years worth of data. So I'm going to type in greater than or equal to now, open parentheses, minus 1095. So now every time this query runs, it's going to find me all of the victim segments for the past 3 years. I'm going to change this to a make table query, and we'll call it victims NIBRS. I'm going to click OK. I'm going to run this, and it's going to say, hey, you're about to paste 2,843 rows to a new table, and then here's our new table. It's showing up underneath all of our other tables, and I can go ahead and save this. Click OK. So I've got these two queries that run. One pulls in 3 years worth of offense segments. The other one pulls in 3 years worth of victim segments, and it makes tables. But I have to run this every day because I want to do up-to-date analytics daily. And I might actually have to go in and create a new query for witnesses and another one for suspects. And I might need to do a 5-year query, and I might need to do a 10-year query. I might, by the time I'm done, have 5 or 6 queries that need to run. And running them all by double-clicking every day and coming in here is somewhat tedious and time-consuming. So we can automate that by creating a macro. Ta-da! And a macro is just a list of commands that you give Microsoft access to run all at once. So you can tell it, every day when I click on this one button, I want you to run query 1 and query 2 and query 3 and export a table of data and export a report that I've made. This makes it really easy to push data around your agency. So in some of the agencies I've worked in, the analyst uses Microsoft Access macros to push or pull data into Power BI and Excel. We also sometimes work with other units. So there's a GIS unit inside the city. Well, they don't necessarily need us to create an analytical product for them, but I can create a macro that will pull data and then push out an Excel of that data to a shared drive, and then they can pick that up every day. And I don't ever have to think about it. And I'm just constantly pushing data out to them, and then they can update their map layers or whatever. So creating a macro in Microsoft Access is really simple. I'm going to make sure that query 2 is saved here. I'm going to close this. I'm going to go up to my top here. I'm going to hit create and macro. And the first thing it's going to do is just show me this drop-down menu here. By default, it doesn't give you all of the possible actions in that drop-down menu. That's really annoying. So I'm going to hit show all actions. And the first thing I'm going to do is type in set warnings. There it is. Now you remember whenever I double clicked on the make table query, it said, warning, you're about to delete an existing table and make a new one. Are you sure you want to do that? I don't want it to do that for every time I run one of these queries. I just want it to run the query. And I don't want it to stop this macro because it's giving me that warning. So that's what set warnings does. It turns those off. After that, I'm going to tell it that I want to open a query. So you can type in open query. And it's going to say, what query do you want to open? I'm going to hit this drop down, and I'm going to tell it query 1. You can then find open query again and add new action, or you can actually copy and paste. So I'm going to come up here and select this little second line here that says open query, and it points to query 1. I'm just going to hit Control-C and Control-V. And then I'm going to change my drop down to query 2. Another really useful thing for pushing data out is export table or export with formatting. So I'm going to come back in here in my drop down menu. I'm going to type in export with formatting. This very first option here is it's going to say, well, what are you trying to export? And in this case, I want it to export out an Excel file of the most recent offense data every day to my desktop. So I'm going to tell it, I want you to export out a table. And then I'm going to tell it what table I want it to export. And remember, I created a query that created that offenses table called offenses NIBRS. I'm going to choose that. I get to choose my format. I want it to be in Excel. So I'm going to choose XLS here. And then it's going to say, all right, well, what is the export file? And you actually have to give it the whole file path here. So I'm going to go to File Explorer. I'm going to go to my desktop. I'm going to find my address. There we go. And we'll tell it, I want to create a file called offenses.xlsx. do that right? Yeah, they're backslashes. Cool. There we go. So when this query runs, it's going to run both of those, or when this macro runs, it's going to run both of those queries for me. It's going to update both of those tables, and then it's going to export that offensive table to my desktop. I'm going to right-click on macro 1, and I'm going to hit save. And now macro 1 becomes an object over there on the left. And let's check it out. I'm going to double-click it. Uh-oh. And it's just that easy. I'm going to double-click it. When I double-click it, it's going to run. And what it's telling me here is that whenever I told it to export out that table, it ran into an error. And I think it might be because I gave it a crappy address. So come back over here. And give it the full path. There we go. C users, Charlie, OneDrive, desktop, journ, offenses.xlsx. Save it. There we go. And so now the macro is run. It doesn't show me a progress bar in the bottom right anymore. And if I come over here, I should now have something on my desktop called journ offenses. There it is. Just updated today. You can further automate this. So if you want, if you name this macro auto exec, like that, capital E, capital A, capital E, whenever this access database opens, it will automatically run that macro. So this makes it a little bit easier to run it manually. Now all you have to do is open this up, and you don't even have to click the button anymore. It will automatically run those things. But further, if you just want this thing to run on its own every day before you get into the office, and then the minute you sit down, you've got up-to-date data set out to you, you can use Windows Task Scheduler. So if you type on your Windows start bar and type in Task Scheduler, you can come over here and you can tell it, all right, I want to create a new option, create a basic task. And we'll call this output data. I want this to run every day, starting tomorrow. The action I want it to run is to start a program. And then I just browse to my Microsoft Access database where I've got all of this stuff set up. There we go. Hit next, and I hit finish. So now every day at the time I gave it, it's going to automatically open up this database. And when this database opens up, this macro runs automatically and outputs all of that data for me. And so whenever if I come in every day at 8 a.m., I can tell Windows Task Scheduler, I want you to open this Access database for me every day at 7:50. And by the time I'm sitting down at my desk, I've got up-to-date data ready to go. Furthermore, if you want to really make this fancy, you can go over to Design View, and you can tell it as a last step in the macro, quit access. And so now not only will it Task Scheduler open it up, the macro runs automatically, it updates all this stuff, and as a last step in the macro, it closes itself as well. So there's not an Access database that's just open up awkwardly on your desktop when you come in every day. So I mentioned at the beginning of this that the point of this is automating analytics. And how do you do that? Well, we've created these SQL queries, and these SQL queries have created these tables that pull data, and we've transformed them, we've cleaned them. You can also create queries that will aggregate. So if I want to come over here and create a new query that will do an aggregation for me, I can pull in one of those offense queries. So this is the offense NIBRS table. This is the table that I made with query number 1. I can come in here and tell it I want to get totals. And again, this is under query design. And maybe I just want to every day get a count of how many offenses have occurred in the past 3 years. Well, one way to do that is to come in here and put in our offense type. And now notice with totals turned on, there's a new row down here. And it's this total row. And we can choose to group by, or there's all these other functions. I'm actually going to add offense type twice. And I'm going to leave one of these as group by and the other one as count. And when this runs, it's now going to give me a count of how many of these offenses have occurred in the past 3 years. Because remember, in the first step, we added a filter that only limits this to the past 3 years worth of data. So I can now save this. Well, actually, I'm going to go back to design view. I'm going to tell it to make a table. I'm going to call it NIBRS offenses count. Now I'll save it as query 3. Tell it to run. I'm going to go back into my macro. I'm going to add a new step in my automation process. I'm going to tell it to run query 3. And I'm going to save. So now every day, not only am I getting raw data outputs from here, but I'm also getting this new table updated that shows me how many of each offense has occurred. What can you do with that? Well, if all you've got to work with is Microsoft Excel, you can do quite a bit. So I'm going to open up Microsoft Excel. And I'm going to tell it, all right, I want to start building a workbook. But the first thing I want to do is pull in some data. And so I'm going to go to data and get data from database from Microsoft Access. And then it's going to say, what Access database do you want to pull from? I'm going to go over to my Journ query Access database. And now all these tables that I've built that are the results of those SQL queries, like offenses NIBRS, victims NIBRS, and that counts table, they're all here. So I can load those. And I'm going to go ahead and get the other ones as well. So I'm going to go to data, get data from database, Microsoft Access database. I'm going to find my Journ query. Pull in my victims. There we go. I can save this. And now whenever I want to pull in new data, every day before I get there, Microsoft Task Scheduler opens up my Access database. It runs the macro. The macro pulls in all the new data. It performs those cleaning and those transformation functions. And I want to build analytics off of that. So I'm going to open up my Excel where I've already connected these tables. I go to data and I hit refresh all. It pulls in the most recent data from Microsoft Access. And now I've got up-to-date data inside my Excel workbook. Well, from here, I can start building out all sorts of formulas that read that data. And those formulas will update. And then any visualizations I build off of those formulas will also update. And so I don't really have a whole lot of time to go into formula building and all of that stuff inside Microsoft Excel, but I wanted to give you sort of an example of what that looks like. And this is an actual NIBRS-based product that I created when I was at the city of Wichita. And as you can see, I've got 4 tables of data here. And the way I got that data into Excel was I created queries in Access. It pulled data from the back end of the RMS every day. I put them into a macro. The macro opened and ran itself with Task Scheduler. And so whenever I wanted to update all of my analytics, all I had to do was open up my Excel workbook, go to data, and hit refresh all. And it would automatically pull in these 4 tables of data from my Microsoft Access database. Well, once I built that data in, I also had all of these formulas. And you'll notice that as I click around on this Excel, when I click on a number, up here in the formula bar, it's not showing a number, it's showing a formula. And that's because the formulas are dynamically reading these columns of data. So when new data comes in, these formulas update their counts. And then every single piece of analysis inside this workbook is referring to those formulas. over here. So whenever I came in here and I hit refresh all, it pulled in these 4 tables of data from Microsoft Access, all of these formulas updated, and then all of these analytics updated as well. And so whenever it was time to answer a question about how many robberies have we had in Patrol South in the past 28 days, well, I had an Excel ready to go, and it was updated daily before I even really got into the office. And because we built all of this in Excel, it's incredibly flexible in terms of the types of things that we could build. And then we even put in a little element of dynamicness to this. All of these formulas read off of this date cell. So if somebody said, man, I don't want to see stats ending the week of 1/12/2019. I want to see stuff that ends the week of 1/7/2019. I could just come in here, type in a new date, and then tell the formulas to update. And now all these formulas are going to update, and all the visualizations are also going to update. It does take a second because there are something like 40,000 formulas in here. And then whenever it came time to share all of this, all I needed to do was highlight the pages that I needed. Like maybe I wanted to share these, I don't know, 5, 6 pages, whatever. I could come in here and then I could tell the Microsoft Excel that I want to print this. I want to print the selected things as a PDF. And now I've got a nice, clean, formatted statistical report ready to go. I also threw in an example of doing this inside Power BI. Power BI works largely the same way. Anytime you want to bring in data and create a dashboard inside Power BI, it's literally the exact same interface. You go to get data. I'm going to tell it that I want to pull data in from Microsoft Access. I'm going to connect. And then I'm going to find my Journ query access database. And then all the tables that I've created using SQL are going to be available to me. And I can pull those into Power BI and I can start building dashboards off of it. Offensive NIBRS, victims NIBRS, and my count table. So I know that I'm out of time, and this was really wanted to focus on SQL here and not necessarily like data analysis or visualization or things like that. But I really wanted to drive home the point that I made in the beginning, and that is that if you're working with SQL, then you're able to create workflows that work like this, that are very automated, that are super easy to maintain and super easy to update later, and allow you to work more efficiently, versus if you're not working with SQL, then you're really limited in terms of what you can produce with those other tools. If this is something that you guys would like to learn more about, if you go to my website, bdeanalyticsllc.com, and go to the Learning tab, there is a webinar here where my amazing colleague, Amanda Bruner, Accelerate Your CompStat, walks through the process of how to create formulas and dynamically driven Excel pages like this. But it all kind of relies on you having a rudimentary understanding of how SQL works in order to pull that data out and automate those things. And of course, if you would like another class on that in the future, using Excel or using Power BI to automate the output of SQL queries that you built inside Access, I'm more than happy to do that as well. But we are out of time, so I am just going to ask if there are any questions. So one question was to explain what I said about the number of victims for each offense divided by the population size. So going back to why we created the queries that we did. So whenever you are looking at statistics within one city, so like if I was just working for NYPD and we wanted to do analytics and we wanted to look at is crime going down year over year, I would probably just look at offenses. So I would look at how many offenses occurred inside the city last year, how many occurred inside the city this year, and I would compare the two. But if you wanted to see how much crime is there in New York City relative to Albany, New York, well, you wouldn't necessarily compare crime counts because there's like millions of people in New York City. Albany is so much smaller. So of course there's going to be more crime. So if you want to compare crime across the two, instead of looking at a count of offenses, you have to look at a victimization rate, which is how many victims of crime do you have in each city divided by the population. Sometimes times 100,000, so you get a rate per 100,000 people or something like that. Well, this has really profound implications for how you write your SQL. And the NIBRS handbook uses the language of offense segments versus victim segments. If I wanted to create analytics and I only wanted to count offenses, then I would write a query that looks like this. I have a table of reports, and I'm going to join it to a table of offenses, and I'd write a query. But if I knew that I wanted to compare crime across cities, well, to do that, I'm going to have to get a victimization rate. So I would do something like this, where I'm joining reports to offenses to people involved, and I would see how many victims of crime have we had in each of those cities. And then I would divide the number of victims by the population size. And that gives you some idea of victimization rate in city 1 versus city 2. And so we did 2 different queries over the course of these 2 different days, one that looks at offense segments and one that looks at victim segments, because in your role, you might be doing one type of analysis or the other. Did that answer the question? And like I said at the beginning, if you guys have any additional questions, oh, Nathan asks, would you recommend using Access as an intermediary step between a relational database and Power BI, or does it make sense to set up a direct ODBC connection via Power BI? It depends. So if the scope of your analytics was we're just building Power BI dashboards, like if I was working by myself in a unit and all I was doing was building dashboards, I would connect Power BI directly to the ODBC connection. That's exactly what I would do. There are certain cases where I would use Access as an intermediary step, especially if you are feeding data into multiple analytic tools. So like if you've got data going into Power BI and ArcPro and Excel and i2 and whatever, I think it's a little bit easier to make sure that all of those are reading the same data to make sure that there's consistency if you have a data management tool in the middle. So there's only one tool that's actually pulling from the ODBC, and it's setting up tables of data inside an Access database, and then everything's reading off of that. It makes it a little bit easier to make sure that all those tools are reading data consistently. It also limits the number of calls to your database. And depending on where you're at, if you're not at a very big agency, that probably doesn't matter. But if you're at an agency and you've got lots of data, every query is taking time, and you've got lots of analysts who are all making direct queries on that database, that can cause network issues and IT issues. And so in that case, I would just say, yeah, just have one authoritative SQL pull that pulls in all of the data, kind of like creating a little mini reporting server somewhere, and then have all of your tools read off of that. So I know it's a little bit of a convoluted example, but if you're just one or two people and you don't have very big data and you're just making dashboards, yeah, I would just connect them directly. But if you're trying to keep a very large pool of data organized among a lot of analysts, I would consider an intermediary step and having everybody connect to those tables that you pull as opposed to connecting directly to the database. Any other questions? Well, I am going to type my email into the chat. If anybody has any questions after today or you want to follow up, by all means, shoot me an email. I'm more than happy to chat with you. And then check out my website as well. I've got some other cool videos on there that walk you through how to do things like paginated reports in Microsoft Access, or using Access to automate link charts. I have a whole Udemy class on that that's absolutely free. So if you're doing a lot of intelligence stuff, All of that builds on what we've talked about in the last days. Whatever your project is, I'm more than happy to point you towards a resource if I know of one or if I have one. But if not, thank you all so much for your time. I really appreciate it. I hope you've all enjoyed it and you've learned something. And if there's any way that I can improve on the content that you saw, please shoot me an email and let me know that as well. Fill out the evaluation stuff. I'd really like to hear what you have to say.